Both direct current distribution boards and uninterruptible power supplies provide backup power to critical equipment in substations during emergencies such as power outages. The key differences lie in their circuitry, input and output voltages, battery configuration, power capacity, efficiency, size, and specific considerations for voltage, load type, battery life, and maintenance. Regarding circuitry, a direct current distribution board distributes direct current power from batteries directly to direct current powered equipment. On the other hand, an uninterruptible power supply converts alternating current power from the utility grid to direct current power for battery charging and converts it back to alternating current when needed. Considering input and output voltages, a direct current distribution board accepts and distributes direct current power at the same voltage, for example 125 volts or 250 volts. An uninterruptible power supply converts alternating current power to direct current and can output alternating current power at a different voltage, such as 120 volts or 240 volts. In terms of battery configuration, a direct current distribution board typically has a single bank of batteries that provides direct current power to all connected equipment. An uninterruptible power supply may have separate battery banks for critical and non-critical loads, allowing for selective power blackout during emergencies. Looking at power capacity, a direct current distribution board is limited by the capacity of its batteries, while an uninterruptible power supply can provide extended runtime by adding additional battery modules. Concerning efficiency, direct current distribution boards are typically more efficient than uninterruptible power supplies due to the lack of conversion steps. Uninterruptible power supplies are less efficient due to conversion losses. Considering size and cost, for the same power capacity, direct current distribution boards tend to be more compact and less expensive than uninterruptible power supplies. There are specific considerations to take into account. Firstly, voltage. For direct current powered equipment, a direct current distribution board is the preferred choice. Secondly, load type. If both alternating current and direct current equipment need backup power, an uninterruptible power supply can provide the flexibility to support both types. Thirdly, battery life. Uninterruptible power supplies with multiple battery banks offer longer runtime, which is crucial for critical equipment. Fourthly, maintenance. Direct current distribution boards generally require less maintenance compared to uninterruptible power supplies due to their simpler design. In conclusion, the choice between a direct current distribution board and an uninterruptible power supply for emergency power supply depends on specific requirements such as voltage, load type, battery life, and maintenance considerations. Direct current distribution boards are more efficient and cost-effective for direct current powered equipment, while uninterruptible power supplies provide greater flexibility and runtime for both alternating current and direct current loads. The direct current distribution board system operates by directly using the stored direct current energy in batteries to supply power to critical direct current loads. This simplicity in design translates to higher efficiency as there are minimal conversion losses. The batteries are connected to the direct current distribution board, which then distributes the direct current power to the designated equipment. The direct current voltage level is predetermined and remains consistent throughout the distribution process. For example, if the batteries are rated at 125 volts direct current, the direct current distribution board will supply 125 volts direct current to the connected devices. The capacity of the batteries directly limits the amount of power and the duration for which the direct current distribution board can supply power. It's also important to note that direct current distribution boards are designed to handle direct current loads exclusively, meaning they cannot directly power alternating current equipment. The uninterruptible power supply system, on the other hand, is more complex and versatile. It incorporates several stages of power conversion. During normal operation, the uninterruptible power supply converts incoming alternating current power from the utility grid into direct current power to charge its internal batteries. Simultaneously, it converts the direct current power back into alternating current power to supply the connected alternating current loads. When a power outage occurs, the uninterruptible power supply immediately switches over to battery power, converting the direct current energy stored in the batteries back into alternating current power to maintain an uninterrupted supply to the connected loads. The uninterruptible power supply's ability to convert power between alternating current and direct current allows it to support both types of equipment. However, these conversions introduce energy losses, making uninterruptible power supplies less efficient than direct current distribution boards. Some uninterruptible power supplies are designed with multiple battery banks. These configurations enable selective power management during emergencies. Critical loads can be connected to one battery bank, while less critical loads are connected to another. This allows the operator to shed non-essential loads to extend the runtime of the uninterruptible power supply for the most critical equipment. The selection between a direct current distribution board and an uninterruptible power supply hinges on the nature of the loads being supported. If the substation primarily relies on direct current-powered equipment for critical operations, the direct current distribution board presents a more streamlined and efficient solution. The simplicity of the direct current distribution board translates to lower upfront costs, reduced maintenance requirements, and higher overall efficiency due to the absence of power conversion stages. Direct current distribution boards find applications in substations where control systems, protection relays, and communication equipment operate on direct current power. These devices require a stable and reliable direct current power source to function correctly during both normal and emergency conditions. The direct current distribution board ensures that these critical direct current loads remain energized, allowing the substation to continue operating safely and effectively. Uninterruptible power supplies are better suited for substations that require backup power for both alternating current and direct current equipment. The ability of the uninterruptible power supply to convert power between alternating current and direct current makes it a versatile solution for supporting a wide range of loads. Uninterruptible power supplies are often used to power alternating current equipment such as servers, computers, and network devices that are essential for substation monitoring and control. In addition, uninterruptible power supplies can also provide backup power for direct current equipment through the use of direct current power supplies. The runtime requirements also play a crucial role in the selection process. If the critical loads require extended backup power during prolonged outages, uninterruptible power supplies offer the advantage of scalability. Additional battery modules can be added to increase the overall battery capacity, thereby extending the runtime of the uninterruptible power supply. Direct current distribution boards, on the other hand, are typically limited by the capacity of their existing battery banks. While it is possible to increase the battery capacity of a direct current distribution board, this often involves replacing the existing batteries with larger ones, which can be a costly and time-consuming process. Another factor to consider is the level of maintenance required for each system. Direct current distribution boards, with their simpler design, generally require less maintenance than uninterruptible power supplies. The absence of power conversion stages reduces the number of components that can fail, resulting in low maintenance costs and downtime. Uninterruptible power supplies, on the other hand, require regular maintenance to ensure the proper operation of their power conversion circuits, batteries, and control systems. This maintenance may include battery testing, fan replacement, and capacity replacement. When comparing the size and cost of direct current distribution boards and uninterruptible power supplies, direct current distribution boards tend to be more compact and less expensive for the same power capacity. This is primarily due to the simpler design and the absence of power conversion components. Uninterruptible power supplies, with their more complex circuitry and additional components, typically require more space and are more expensive. Finally, the choice between a direct current distribution board and an uninterruptible power supply depends on the specific voltage requirements of the critical loads. Direct current distribution boards are designed to provide direct current power at a specific voltage, such as 125 volts direct current or 250 volts direct current. If the critical loads require a different direct current voltage, a direct current to direct current converter may be needed. Uninterruptible power supplies, on the other hand, can provide alternating current power at a variety of voltages, such as 120 volts alternating current or 240 volts alternating current. This makes them more versatile for supporting a wider range of equipment. In summary, the decision between a direct current distribution board and an uninterruptible power supply involves a comprehensive evaluation of factors such as load types, runtime requirements, maintenance considerations, size, cost, and voltage requirements. By carefully considering these factors, engineers can select the most appropriate emergency power supply system for their specific substation application, ensuring the reliable and uninterrupted operation of critical equipment during power outages. The efficiency of a direct current distribution board stems from its direct connection to the battery source and its direct delivery of power to direct current loads. This eliminates the need for inverters or converters, which are inherent in uninterruptible power supply systems. These devices, while necessary for alternating current power delivery, introduce losses due to the conversion process. As a result, a significant portion of the energy supplied by the batteries is effectively used to power the direct current equipment, maximizing the overall efficiency of the system. In uninterruptible power supplies, the process of converting alternating current to direct current for charging the batteries and then converting it back to alternating current when the main power source fails results in energy dissipation in the form of heat. These losses, while not drastic, add up over time and reduce the overall efficiency of the system. The efficiency of uninterruptible power supply is also affected by the quality and design of its components, such as the inverters and rectifiers. High-quality components can minimize losses and improve efficiency, but they also add to the overall cost of the system. Moreover, the efficiency of uninterruptible power supply tends to decrease as the load decreases. This is because the fixed losses associated with the conversion process become a larger percentage of the total power output at lower loads. In contrast, direct current distribution boards maintain a relatively constant efficiency regardless of the load, making them more suitable for applications where the load varies significantly. In terms of size and cost, the direct current distribution boards benefit from their relatively simple design, requiring fewer components compared to uninterruptible power supplies. A direct current distribution board primarily consists of the battery bank, protective devices such as fuses and circuit breakers, and a distribution panel for connecting the direct current loads. This simplicity translates to a more compact footprint and lower material costs. Uninterruptible power supplies, on the other hand, incorporate a more complex array of components, including rectifiers, inverters, battery chargers, and control circuitry. These components add to the overall size and cost of the system. In addition, uninterruptible power supplies often require cooling systems to dissipate the heat generated by the power conversion process, which further increases their size and cost. The specific voltage requirements of the equipment being powered also play a significant role in the selection between a direct current distribution board and an uninterruptible power supply. Direct current distribution boards are designed to provide direct current power at a specific voltage level, typically 125 volts direct current or 250 volts direct current. This voltage level is determined by the battery bank and is typically not adjustable. Therefore, it is important to ensure that the direct current loads are compatible with the direct current distribution board's output voltage. Uninterruptible power supplies, in contrast, offer more flexibility in terms of voltage output. They can provide alternating current power at a variety of voltage levels, such as 120 volts alternating current, 240 volts alternating current, or 480 volts alternating current, depending on the design of the inverter. This makes them suitable for powering a wider range of equipment with different voltage requirements. In addition, some uninterruptible power supplies can also provide direct current power through the use of direct current power supplies. These direct current power supplies convert the alternating current output of the uninterruptible power supply into direct current power at the required voltage level. This allows the uninterruptible power supply to support both alternating current and direct current loads. When selecting an emergency power supply system, it is crucial to consider the criticality of the loads being supported. Critical loads are those that must remain operational during a power outage to prevent safety hazards, equipment damage, or significant financial losses. Examples of critical loads in a substation include protection relays, control systems, communication equipment, and emergency lighting. For critical loads, it is essential to select an emergency power supply system that can provide a highly reliable and uninterrupted power supply. Direct current distribution boards and uninterruptible power supplies can both provide reliable backup power, but they have different strengths and weaknesses. Direct current distribution boards are generally considered to be more reliable than uninterruptible power supplies due to their simpler design and fewer components. However, direct current distribution boards are limited by the capacity of their batteries, so they may not be suitable for applications where extended runtime is required. Uninterruptible power supplies, on the other hand, can provide extended runtime by adding additional battery modules. However, uninterruptible power supplies are more complex and require regular maintenance to ensure their reliability. The choice between a direct current distribution board and uninterruptible power supply for critical loads depends on the specific application and the level of reliability required.